Assalamu alaikum. My name is Sultan Khan, and I was a principal of Jamia Millia Polytechnic, Karachi during the 1990s, long time ago. And today I'm presenting to you a video program, self-learning program on the topic of basics of electricity or fundamentals of electricity. And the contents of this video will be some discussions on electrical charge, and then followed by electrical current, electrical potential, and then describing the two types of currents, alternating AC and direct current DC, and finally the units of measurements of all the above. So if we talk about what is electricity, so we know that electricity, the phenomena, is not new. It has been there since the creation of mankind in form of the thunders and the lightning strikes and the resulting deaths and falling of trees and etc. And also when you touch metallic objects during dry weather, especially cold weather, dry weather, and you're wearing woolen or furry clothes, so you will get a painful spark or a pain when you touch some metallic objects. So that was what was the initial knowledge of the people thousands of years ago. But the understanding of this phenomena, of these sparks and this pain, started like 300 years ago, when the man was able to understand the mystery of electricity and make it so useful that today we cannot even imagine that the world can be without electricity. So we are so much dependent on electricity that everything, practically everything, runs on electricity. So to understand the mystery of electricity, we need to understand or review our knowledge, basic knowledge of atomic structure and the concept of electrical charge. So let's talk about the atomic structure first. Now, we all know from our basic physics that all matter is made of atoms, and each atom is also comprised of several subatomic particles. The most common that we know are electrons and protons and neutrons. And there are more, but those are not of our real interest in this topic because they don't contribute towards the flow of electricity. Now here on the left is a basic model of an atom, and we know that it has a central nucleus which is called nucleus, and it contains protons and some other substances or elements as well, or particles as well, like neutrons and some others. They don't revolve. They are like a unified bunch of particles, and around them are circulating other particles which are free to move. So these particles which are circulating in orbits around the central nucleus, these are called electrons, the red ones. And the blue or the green ones here in the center of the nucleus, they are called protons, and we'll talk about them. So fundamentally, they have opposite charge, and let's talk about that. So electron has negative charge. So the red balls here, they have electrical charge, and protons, which are in the center, these protons, they have negative charge. Now what does it means that one has a positive charge and the other one has a negative charge? Is very simple. When people who are working on this like 200 years ago, they have to give a name each to the electron and proton to tell that these two charges behave as opposite to each other. Their characteristics is opposite to each other, meaning they will attract to each other like charges attract each other. So they gave electron as a negative, the negative name, and proton was given the name of positive charge. Now each atom, this whole thing, one atom, has a nucleus which is the center, which comprises of protons and neutrons, and each atom is circled by multiple orbits, and it can be many orbits, it can be a single orbit as well, and that will depend on the number of protons and electrons, and we will talk about that later. Okay, so the number of protons here in the nucleus, that determines the atomic number, or it is called the atomic number of that substance, like copper or silver or gold or oxygen, and etc., etc. So each of the fundamental element in nature, it has an atomic number, and it is based on number of protons in the nucleus. And valency is the number of electrons in the outermost orbit, and we will talk about that in the next slide. So here, let's talk about the atomic structure and valency. Now, in here, we have an atomic representation of copper, Cu. Now, copper has a valency of 29, meaning it has 29 protons in the nucleus. And because copper is a neutral element, so it will have the same number of electrons, so that there is no charge on it, and the positive charge cancels the negative charge. So there is a law which will determine how these 29 electrons will be by nature distributed in the different layers of orbits that will be circulating around the center nucleus. Let's see that. So there is a formula for that, and the formula is 2n square. So the number of electrons in any orbit is given by 2n square, where n is the serial number of the orbit. Now let's try to distribute these 29 electrons around a nucleus of copper. We know the formula says that 2n square, where n is the serial number. So if we go for the first orbit, the purple one, its serial number is 1. So 2 times 1 square, which is 2. So and we see that the first orbit carries a maximum of 2 electrons. So out of 29, 2 are gone. Remaining are 27. Rest will be distributed in the second and the third and the fourth. So let's talk about the second one. Now second one, the number is 2. Second means 2. So n becomes 2. 2 to the 4 and 4 to the 8. So in the second orbit, we have 8 electrons fixed. Now 8 plus 2, we have 10. There is still 19 to go out of 29. So the next orbit will open, third. The serial number is 3, third. So n is 3, 3 the 9. 3 square is the 9, 9 times 2, 18. So you will see that the third orbit has a maximum of 18. So now we have fixed 18 plus 8, which is 26, and 2, 28. How many are remaining? 1. So that will go to the last. It will create another orbit, and you will have only one electron in the last orbit of a copper atom. So here is the same thing that we just discussed. The first shell, this purple, will only have 2. Second shell will have up to 8, maximum of 8. We see this here in the blue one. The third shell can have a maximum of 18. We see that in this green orbit. And the balance, which is only 1, is here in the last orbit. This outside, the external electron is the foundation of electricity, and we will talk about. So this is the foundation of the flow of electrons, which is flow of current. So summarizing, copper has 29 electrons, and the distribution is shown here, which is this diagram. So remember this. So let's go to the next slide. We don't know that. I think before we go to the next slide, let's talk about a question that you might be thinking. Why all these electrons are forced to circulate in circles or in orbits? Why don't they move out of their orbits and become independent? Why are they attracted, or which force is there which makes them circle their central body? And the answer is the same as we have for Earth moving around the Sun in 365 days and Moon circling the Earth in 29, 20, or 30 days. What is keeping them in their paths or in their orbits is the gravitational pull which the Sun has on the Earth and Earth has on the Moon, the Sun, and also the Moon has on Earth and Earth has on the Moon. The mutual attraction, the gravitational pull between the two objects, is forcing them to come together. But because they are moving, they don't come together, they keep circling. They keep circling. Exactly in that way, unless we do something disastrous here, apply some external force, this atom will continue to behave in this manner. Continuing on the atomic structure and the same copper atom. So here, this last electron, the last orbital electron, is called the valence electron. So electrons in the last shell are always called valence electrons because they are the external-most particles, and these are the particles that will take part in the flow if some external force is applied. If I apply a force here on this atomic structure will remain the same, no change, but this will be dislocated like you do like this. So if you put a finger on a stone and you do like this, the stone will be taken out. So that's the exact description of that. So if we are able to dislocate this valence electron, we can end up with having electronic current. So in copper, and that's the reason why copper is one of the most popular conductor of electricity in electrical engineering, because it is easiest to break, to have their valence electron taken out, because it's only one. So it is easy to apply just a little force and these electrons will start flowing, and let's see that. So take this example. So it's a copper wire. These are 4 atoms actually. There will be millions and millions of billions of atoms in a wire. We are just showing 4 here, and we are not showing the internal electrons here because they are not of interest to us. We are only talking about the external ones, which is 1 for this copper, 1 for this atom, and this is one for this atom, this is one for, and so on. There are millions and millions of copper atoms here where the last electron is free to move. So if we apply a force here, in this way, so this can break away, and this will be attracted by this, and this will be attracted by this. So they are pushing each other. So these valence electrons keep pushing each other from left to right. If we apply a force from right to left, they will push in this direction. So electrons will start flowing in the wire. Now, the flow of electrons is the basic definition of current, electric current. So electric current is defined as flow of electrons. So if we apply some force, that force can be of friction or a battery or your power from your socket, and then the current starts flowing. So it is nothing but the flow of the valence electrons. Okay, so let's talk about the types of currents. And we have already talked that we are able to flow or create current here. There are two types. One is DC, direct current. So this is what direct current looks like. In here, it flows in one direction only, meaning if this is a copper wire and we apply a battery, one terminal here and the other terminal here, and switch on. So if this is the positive terminal connected to this, so electrons will start flowing from my left to the right, back to the battery, inside the battery, and come back. So they will always form this circuit. Now remember one thing, we talk about that the current flows from positive terminal to negative, which is not really true. This is the old version. New knowledge says actually they flow from the negative to the positive, but we will not confuse you here. Keep considering that the current flows from the positive to negative. So in DC, the current flows like this. When I do this, means the current moves within the battery as well, within the plates, within the acid. So it's a complete circuit. Till we remove one of the wire, it will continuously keep flowing in this wire. And this wire can be a bulb, can be anything. Okay. Contrast to this, alternating current, it flows in both directions here. And here you will see that here the arrow, here it was a single direction, but here you will see it's a bi-directional, two-direction, meaning this wire, when AC flows through it, for some time, milliseconds, the current will flow, say, from my left to right, and then it will reverse and it will flow from my right to left, and then again left to right, and this will depend on what we call frequency, how many times per second this wire changes its direction within this wire or this bulb or anything else. So in Pakistan, the frequency is 50 cycles per second or 50 hertz, meaning in 1 second the current flows 50 times and 50 times. That is 1 cycle. So one left to right and one reverse right to left is 1 cycle. So this happens 50 times in 1 second. So you can see how fast that is. So AC is the current which flows in both directions depending on the frequency. Now talking about the frequency, which is measured in hertz, in electricity it is 50 hertz, in USA it is 60 hertz, and for electronics we talk about kilohertz, thousands of hertz. In satellite technologies we talk about megahertz and gigahertz. So these are all frequencies, cycles per second. So imagine 1 kilohertz is 1000 cycles per second. How fast the current is changing the direction. Or megahertz, million, 10 lakh. And similarly, gigahertz, that's like a trillion. So this is the way. By the way, there is no frequency in DC. If someone asks you what is the frequency of DC, your answer is there is no frequency. Even we cannot call it zero. There is no frequency. There is no concept of frequency because there is no change in the direction of it always rotates in one direction, either from here to here, or if this is the positive, it will flow from here to here. If this is the positive, like this, if this is the positive, and so on. Okay. So let's talk about electric potential or pressure. Pressure or potential is defined as the difference of electrical charge between 2 points. Potential is also called pressure and is measured in volts. Take this example. So we have a wire. On one end, it has higher potential because there is a positive charge, and the other end there is a negative charge. They are opposite in nature, so they will be attracted, and there will be a flow of current from one direction to the other, from positive to negative, whereas the right answer is from negative to positive. Now, this flow, just like water, depends on the pressure applied. So if you have a pressure applied to a pipe, water containing in a pipe, and you apply a pressure, if there is no pressure, the water will not flow. But if you apply pressure, the water will flow from the higher pressure to the lower pressure, exactly in the same manner. So in this example, I was thinking of telling you what the potential is and how the volt works in electrical engineering. So here is the volt, 230 volt. So this is a motor, actually, three-phase motor working at 400 volt, three-phase, and single is 230 volts, three-phase. We have not talked about phases, but let's just hear the values, 400 volt, and this is 230 volt. And then the battery that we talked about earlier is 12 volt, and the AAA and the 2A cells that we have, they are 1.5 volt each. Okay. So unit of charge, which is the particle that we talked about, is measured in coulombs. Symbol is C. Current is measured in amperes. Current is the flow of electrons, which is moving from right to left or left to right, and in AC, which is moving in both directions. So that current is measured in amperes, unit is A, and pressure or voltage is measured in volts, the unit is V. And here is one nameplate of a motor, which tells you actual values of amperes here, and actual value of cycles per second or hertz here, 60 cycles, and the volts are here, 220 slash 115. So it's a 2 voltage motor. It can run on 115 as well as run on 230 volts. If it is running on 230, it will take 6 amperes, and it is running on 115. Let me switch on this. So here, 60 hertz, single phase, volts are 230 and 115, and the amperes are 6 amperes and 12 amperes. Meaning if it is running on 230 volt, it will take 6 amperes, and if it is running on 115 volt, it will take double the amperes, 12 volt. And so this nameplate, the values are shown here, just to tell you what a nameplate means. The other thing is horsepower. It's a single horsepower motor, single phase. Insulation class, we don't talk about that today. Phase 1, ambient temperature. This should be the temperature it should be run. If you run it higher than that, you have a chance of overheating it, and it runs on 60 cycles per second. So this is not a motor that can be run in Pakistan because we have 50 cycles. It can be run, this might be an American motor to be run in USA. We'll talk about this later, and we take a break here. So in here, this is another concept actually. The concept is when there is a charge in a matter, in a particle, in a substance, depending on what charge it is, which will depend on the number of protons and electrons in that substance. If there are same numbers of electrons and protons, that becomes a neutral particle, neutral body. It has no charge. But in this case, you will see the electrons are more than the protons. So this particle has a net negative charge, and that charge attracts things towards itself. It is an inbound force. Whereas if a substance is positive, because the protons are more than the electrons here, it will also create a force, but this force will be going outside, away from the particle. So you will see that they are opposite to each other. And this charge is measured in Coulomb. And the main concept here is that opposite charges will attract each other. And the reason is that this charge is trying to go this way, and this charge is trying to pull something from here to here, meaning both are attracting to each other. They are attracted. So if they are free to move, these two charges will combine as one. They will come together. If we place a positive charge here and a positive charge here, you can understand what will happen. They will fly out of them because they are repelled by them. If we have two negative charges here, it will be the same. They will fly away from each other. The charge, the concept of the charge and the use of this charge will be done in another lecture. This is not the topic of this lecture, but this was important to tell that when you have charge in a substance, it has a direction, either positive charge or negative charge. So we have already talked about that, and that's the reason there is a universal saying that opposite charges are attracted and like charges are repelled. Like two magnets, North Pole and North Pole will repel each other because they are like, and a North Pole and a South Pole will attract to each other because they are opposite. So this is law of nature. So here we close this lecture. I hope you were able to refresh your memory and try and understand. Talk to your teacher. He will be able to explain more where you have any clarity required. So otherwise, thank you.